circuit. The right side doesn't require the same kind of mass because it's only going to the lungs, which are actually next door. They're right, in the mediastinum, on either side of the mediastinum. So it doesn't take much, and so the muscle is quite a bit smaller. So basically we distinguish the two sides. Now, the other things that you can see here on this particular one, you see this area right at the top where I'm kind of grabbing onto that. This is part of the atrium, okay? And the question you should is, well, how do I know which atrium it's going to be? Well, if it's going into the left ventricle, then obviously it's the left atrium. Now the atrium, and you can see the other side of that, the other piece of it over here. And notice on this one also, the pulmonary vessels were basically cut off. So you don't see any vessels there.
So where's the right atrium at then? There's not
So the right,
there.
well, it's actually up here. So let's look at, so if I go up in here, here's the right atrium, right over here. So there it is right there. And I'll see if I have one where I've opened that up a little bit more. And that's still pretty closed. There we go. So if we look at it here, if you spread this open, this one's kind of open. I've opened up the right ventricle here, and you can look upward into this chamber. And so there you see, I don't know if you can all see that. If you look upward in there, you can see it. If you look towards the top, that's the atrium up there, okay? And you can tell there's a couple of little flaps of tissue in there that we're going to focus on in a minute. But that distinguishes, that's the division between the atrium and the ventricles, and those are the valves. So there's two sets of valves that we have to look at. One set are input valves from the vessels, from either of the two atria, from either the left or right atrium, and the other output valves that basically are at the base of the aorta and base of the pulmonary trunk. So when we look at these, and we'll look at the left side first, these valves are basically fleshy flaps, which you can see them right here. Here's the flap right there. There's a piece of one here. Here's another one that's actually pretty good. This is where it's largely intact. At least I've cut it in half. There's one side over there, another side over here. So these, I haven't said. No. These actually lie between the atria and the ventricles. And so they're called, in the general term, is atrioventricular valves. Okay? So on the left side
Is that the mitral valve then?
is basically the bicuspid or mitral valve.
Okay.
The right side, there's three cusps, which you can't see in that one, and that's called a tricuspid valve. Okay? So the actual right side, and here you can see that in this one that's opened up. You can actually make out two of the three cusps. This one's partially cut. Here's the second one here, and here's the third one over here. So the tricuspid valves is between the right atrium, right ventricle. And there are three cusps. On the left side, there are two cusps, and this shows one of the two over here, and that's called the bicuspid valve or mitral valve. And the significance of that is, you say, well, why is it that you have three on the low pressure side and two on the high pressure side? It turns out that actually two closing together, basically, because when they close together, you notice these other little strands that are in here that are kind of holding them down. These little structures are called chordae tendineae. I think that's the bottom of your list somewhere. Okay. These are significant because they actually act as little guy wires to prevent these valves from blowing through. So if this is what they are, little wires like my fingers. When it contracts, the fleshy parts of the valve, come together, and those are held in check by the tension of the chordae tendineae. Okay, so they don't blow through and allow regurgitation of the blood back up into the atrium. And so the other things that are part of that, and I'll show you on this one because it shows it nicely. Here you see the part of the mitral valve, and you see the chordae tendineae, and they're attached to this big muscle mass that's in the middle of the chamber here. Okay, and so these are the papillary muscles. Okay, so the papillary muscles are these guys that they're attached to right here. See these little bumps? I don't know if you can see that.
That's
here's,
the tendinae.
that's where the chordae tendineae are attached to the papillary muscles. And so what happens is, so you get an idea, when the heart contracts, and we're going to talk about this more next week when we look at the contraction cycle. But when the heart contracts, it actually contracts beginning at the apex and contracts in almost like a tube of toothpaste. It squeezes in, but it also, and I can't do this totally, it goes in and scrunches up at the same time. And that's from the major portions of the myocardium here. But at the same time, the papillary muscles also contract, and they increase the tension by contracting on the chordae tendineae. That allows these to close, but it prevents them from actually everting. Okay? So this is part of the control mechanism. It's a very exquisite setup. Now, when you get a heart murmur, and they listen to see which valves are actually murmuring, that means that there has been incomplete closure or a partial eversion of either the bicuspid or the tricuspid valve. Now, if it's in a young person, it could be because these things have everted, in which case you can hear the backflow. If it's an older person, then it's probably because the edges of these have become frayed. Okay?